How's it going, everyone? Adam here from Coding Basics, and welcome to tutorial number 11 in my Programming Leap Motion with Java series. Now, I know in the last video I said that one was the last tutorial. Kind of had a change of heart since then. All the videos were kind of showing you different data you could get from each, hand, finger, gesture, say. But I never really gave you a practical example of how you can use all that. Well, before I decided to make this tutorial, I was actually working on a program. I'm working on this program that I'm going to upload for free on my website called Touchless Computer, which I'll just launch it for you. And, okay, it's good to go. And see how it follows? Well, you can't see because I have my, I'm only screen capturing. But, it basically, one second. Just to explain all that's happening right now. Come on. Just to explain what was happening, it used the leap motion, and when my cursor was going around, it was actually following my index finger. So you couldn't see it because I'm screen capturing, not and I didn't have my webcam on, so you wouldn't be able to see it, but you're just going to take my word that it was following my index finger. Why all those windows were popping up was I also used this library called Sphinx, which is a voice recognition library. So, yeah, it was picking out my voice, and it tries to match up what I say with the closest, most accurate command that I have. So, that's what was happening there. What I am going to do now is I'm going to launch this, and then I'll just say one of my actual commands. So I'm not going to talk for a second. Computer YouTube. Alright, so when the light turned green, that means the microphone was ready. Computer is what I use to kind of like get the attention of my program. And then the words that follow represent a command. I said computer YouTube. It launched Internet Explorer to YouTube. So that's kind of what that is. But anyway, all I'm focusing on in this video is the motion tracking with the leap motion. In a later video, I'll go over speech recognition if you're interested in that. But let's get started. So I'm going to create a new project. New project. I'm going to call this leap. I'm going to call it mouse, I guess, because it's taking the place of a mouse. I'm going to use Java 7. Just remember the leap library is only compatible with Java 6 or Java 7. So next, libraries, add external jars, and I'm actually already in the folder, but you go to wherever the leap SDK folder is that I showed you in the first tutorial, into the lib folder, you can put import leap java.jar. Click on this arrow to drop down this menu. Click on native library, edit, and scroll down. Go into where you have the library, and I'm going to use the 32-bit library. And OK, and finish. So we're good to go. If we drop down this leap mouse project arrow, and then we drop down reference libraries, we'll see our leap library is now there. If you have no idea what I was just doing, go back to watch tutorial number 1 of this series where I go over downloading and importing the leap motion library. So we're going to go new, class. Let's call this one, let's call this leap mouse as well, and why not? So leap mouse. And public static void main. We want to include, and click finish. So first, in the beginning it's going to be quick because I'm just going over some of the stuff I talked about in previous tutorials, but then I'll slow down and explain the stuff that's new. But first we got to import our leap library, so import com.leapmotion.leap. Semicolon. So that's how we're going to get our leap library in. So what are we going to do here? Well, first we need to create our leap motion listener. And for that, we are going to create a class. So class, we'll call this custom listener, and it's going to extend the listener that's part of the Leap Motion library. So Leap Motion library has its own listener, and that's what this class is extending. What we are going to do, we are going to create an on connect method. So public void on connect controller C. And in here, what we're going to do is we're going to use this controller called C and add enable gesture. So enable gesture, and we are going to pass in gesture type underscore circle control C, and then it's going to do this for the other gesture types that we're going to be using. So the ones we're actually going to use are the swipe gesture as well. Oops, swipe. And then finally we're going to be doing this for the screen tap gesture. So we'll go over how we're going to do it later, but basically the circle gesture is going to be for scrolling up and down pages, like an internet page, for example. The swipe gesture is going to be to launch the start menu so we can click on our applications. And then screen tap is going to be clicking, so it's going to emulate a mouse click. So now that we got that enabled, we're going to do our onFrame method. Oops, public void onFrame controller C. And for this method, a couple things. First, actually, wait a minute. I think actually I'm only dealing with finger. Let me just look at my notes just to make sure I don't forget. All right, so yeah. First, we got to create our frame. So frame equals c.frame. So it's going to get the most recent frame from our controller, our Leap Motion controller to be specific. Oop, I forgot to give it a name, so we'll call it frame just to be that original. Next, what we're going to do is create an interaction box. Now, let me create a new window. Leap Motion interaction box. If you look here, good explanation of what the interaction box is. The Leap Motion has 150-degree angles that it can detect in. So, you know, it's almost like a upside down pyramid is the area that the Leap Motion can detect movement and gestures in. The interaction box it's like a square area, which is going to be better since we're moving a mouse around the screen. If we wanted to move something to the top corner, if we didn't use interaction box, we'd have to go all the way out here. But then if we went straight down, well, we'd want the controller or the mouse position to go down. But in reality, what would happen would be like it wouldn't pick that up because it would be outside the zone then. So this is just a lot better, especially for what we're doing because we're working with a square screen. So to create an interaction box, interaction box, this is part of the Leap library as well. We'll call it box, and we'll set it equal to frame.interaction box and semicolon. What we're going to do with this interaction box for finger f in frame dot fingers. The frame dot fingers method returns a finger list, a special type of list, part of the Leap library. And now what we're going to do is check to see or determine which one's the index finger. So what we're going to do is our mouse cursor is going to follow my index finger around the screen. So if f.type equals finger dot type index. So if it's our index finger, in a lot more simple words, if it's our index finger, what we're going to do in that case is create a new vector, vector finger POS for position, finger position. We're going to set this equal to f dot tip position. Now, I will come back to this in a minute. We're actually going to change this from tip position. I'll explain why later. And it'll also kind of give you a choice if you didn't want to do what I'm going to talk about later, but well, I'd use it. So what we want to do now that we have this position, we are going to normalize the point using our interaction box. What does that mean? We are going to get the coordinate based on our interaction box, I guess is the best way I can put it anyway. So vector, call it box finger position, so the position in our interaction box, and we'll set that equal to box dot normalize point, and we're going to pass in our finger position. Okay, now we have to first get our screen size. What we are going to do is, to do that, we are going to create a new dimension. So dimension screen equals, we're not going to import for this. We could import the java.awt.toolkit, but I don't want to do that because we're only using one. So java.awt.toolkit dot get default toolkit dot get screen size. Why we're doing that, because we just have a coordinate here, but it's not going to match up with our computer screen. So we're getting the computer screen, that way we can get a proper scale. Now, just to make dimension work, we have to import Java. Let me see if I remember the library this is in. Java.awt.dimension. Yes, I did remember. Sweet. Alright, and now that's all taken care of. And what we're going to do now is actually update our position, like the cursor position. For this, we're going to use a Java library called robot. So let me go back to internet here. Java robot class. Yeah, this is going to be a long tutorial, guys. Sorry, but I didn't want to split this up into multiple ones. So this is our robot class, and it can emulate mouse clicks. So the mouse move method to move stuff around the screen. What else can it do? It can do a lot of stuff. Scrolling. I know there's a mouse wheel. Yeah, mouse wheel. And that's what we're going to be using with our circle gesture. So now that we have our screen size, let's move it. Well, we're going to create a public variable. So public robot, and we're going to call it robot. And we're going to set it equal to new robot. And there. Now we got to import our robot class. So import Java. I forget which library it's a part of. I'll be honest about that. It is in the java.awt. Okay. Java.awt.robot. And why aren't you wanting to work? Oh, yeah, that's right. We have to do a try. I forgot about that. We have to do a try catch. So just forget what I said. So on our on frame method, we now have to create this new robot each time. So robot equals new robot. But this has to be in a try catch statement, so I'm going to try to do this. And we'll catch for exception E, just to eliminate all possibilities. Okay, and now that's taken care of. So to move it, to move our cursor position, we're going to do robot dot move. Why didn't that work? Robot dot mouse move, sorry. I thought it was move mouse, but no, it's mouse move. And now we are going to pass in our coordinates. So to properly line it up, I showed it before, but I'll show it again. Leap motion vector. So the y value is going to be 0 right on the screen. X value is positive to the right, negative to the left. We're not going to worry about the z-axis because we're working on a 2D screen. And to make sure that the cursor is at the right position based on the y value and x value, what we have to do for our x value, we have to type in screen, which is this dimension we got up here, dot width. And what we're going to do is multiply that by our, so I'm just looking at my notes, we're going to multiply that by our box finger POS. But this is not going to work because, box finger position dot get x. Come on, get x. This is not going to work though because right now this coordinate is a float. So what we got to do is we have to typecast this to an integer by surrounding this. Okay. And now same thing for the y value. Well, not exactly the same thing. The y value we have to minus the y value, then multiply by the screen dot height. So for that, int, and then screen dot height minus box finger position dot get y times screen dot height. Okay, now let's test what we got right now. So in the main method, let's first create a new controller. So controller C equals new controller. Now, actually, before I do that, we gotta create our leap listener. So custom listener L equals new custom listener. Then C dot add listener, pass in L, and we are now going to, let me just flip to that page in my notes quickly, just so I don't screw this up. Where are you? Come on, come on. Well, for some reason I can't find that page, so I'm going to go off of memory here. Why not? So I believe it's a try, and then in here system dot in dot read. I believe that's what it is. catch. And we'll put in exception E to cover all possibilities. And it's not going to do anything on the catch statement, but when it's done, we're going to have to remove the listener. So C dot remove listener L. If my memory serves me correctly, that should be everything. So let's run it. And we got an error already. So, okay, now it's telling me I need a 64-bit version of the Java library. That's weird because I used the 32-bit for the last one. But okay. So Java build path, let's change quickly. Change our 32-bit library to our 64-bit library. And that should work now. So, as you can see, I'm moving my finger above the leap motion, and it's following my finger position. I'm moving my finger really quickly, quicker than I could on a mouse. But now watch. I'm going to try to stay, I'm trying to hold my finger still, but my cursor is still moving around. Now, if you want, I'm going to give you the choice here. I'd recommend it. If you want, instead of just getting the tip position, you can get a stabilized tip position. Did I spell that wrong? I better just dot stabilize tip position. Okay. Now let's run it. Oops, I got two hands in. I'm trying to hold my finger still right now, and it's doing a much better job. The human body can't stay completely still, so that's what that method's for, to give you a more stable tip position. Alright, now that we got that done, let's start working with our gestures. So, for our, let's start with our circle gesture. So, let me just flip to that page. Okay, I'm already there. Next, we're going to do for gesture G in frame dot gestures, and I did a case switch statement in my the whole series for our gestures, but I'm going to do an if statement now. So if G dot type equals, why didn't that work? If G dot type I don't know why that didn't work, but okay. If G dot type equals type dot circle, or sorry, type underscore circle. Well, first we want to figure out if the mouse is going clockwise or counterclockwise. If it's going clockwise, we're going to scroll down. If it's going counterclockwise, we're going to scroll up. So in that case, let's start with creating our circle gesture. So circle gesture C equals new circle gesture, and as the parameter we're going to pass in G. Now to determine if it's clockwise or counterclockwise, I did this in an earlier tutorial, but I'll do it again. So if circle, or I guess C, sorry, I named it C. I have it just circle in my notes, but I have it C here. So if C dot pointable dot direction dot angle 2, in the angle 2 we're going to pass in circle dot, or sorry, C dot normal, and we're going to say if it is less than or equal to math dot pi divided by 4. Well, this is the, if this is the case, then we know that it is clockwise. Now I just noticed one error here. I forgot that I had C defined up here, so I'm actually going to call this circle now. I should have done that to begin with, but whatever. So circle and circle. I think, yep, that should fix everything. Great. Now, if it is clockwise, then what we're going to do is robot dot mouse wheel, and we're going to pass in 1. So we want to rotate down 1 each time. So let's run this now. Run. I'm going to start drawing a clockwise circle, and it scrolled down. Now, it's kind of hard to show because this isn't really a long page, but it would quickly go down. Because think about it, every time in the tutorial series when I did one circle, it printed like out the message that we had for each little bit of the rotation. So it would scroll down to the bottom quickly, and that's not what you want if you're trying to slowly go down the page. So after we scroll it once, we're just going to sleep our program for a couple seconds, a couple milliseconds actually, just so that doesn't happen. So try thread dot sleep, and we're going to pass in 50 and semicolon, and our catch statement once again is going to be exception E, open close curly braces. So that would slow it down. Now we're going to do an else. So if it's not clockwise, then it's counterclockwise. Just copy these 2 lines, paste them in here, and just switch the 1 to a -1. So let's run this now. Run. I'm going to start by going counterclockwise, clockwise, counterclockwise, clockwise. So that's pretty cool, right? Not even having to use a mouse to do that. And now let's move on to another gesture. Now that we have our circle one taken care of, let's go on to the screen tap one. And what we have to do for that is, oops, I want to do it inside the for loop. So else if, I'm just going to copy this here just to try to speed this up a bit. And instead it's going to be type underscore screen underscore tap. And when we have a screen tap, we're going to use the robot class again and use the mouse press method. So robot dot mouse press. Now in here we want to first simulate the clicking of the left button, and then we have to release it. So the mouse press clicks down, but it doesn't release it until you tell it to release the click. So input event dot button 1 mask, to be more specific, and finish that off with a semicolon. And we're going to do the exact same thing now, except we are going to change the mouse press to a mouse release. Now it's kind of hard to just show this. I'll try. So I'm going to move over to our stop if I can. Come on. Alright, now if I click, I'm trying to terminate this. See, this is where Leap Motion has a little bit of work to do, but okay. Well, it's not cooperating for me. Okay, there we go. I finally got the click to work. Doesn't pick up on every gesture, but as the library improves, it will get a lot more accurate. Now, the final thing, if you guys are still here, I am going to go over swiping. So, once again, an else if statement. But for this one, it's going to be swipe. And we are going to do the key press thing again. Alright. Sorry, it's key press, not mouse press, so I couldn't copy that. Robot dot key press. And in here we're going to pass in key event dot vk, not wk, vk underscore windows. That's all in capitals as well. And let's do that. We're going to have to import the key event class. So import key event, which I'll show you up here, is java.awt.event.keyEvent. And now we're going to do the same thing, but the key release. So key release. And it's going to release that. Now, one thing I'd also like to point out, just like the circle gesture, every time we did a swipe, there's multiple parts to it. So the starting of the swipe, all the updates, and the end of the swipe. So just one swipe, it would call start many, many times. The only way the start menu would show up would be if there was an odd number of swipe gestures detected in that sequence. So all we're going to do is add another situation. So where do I have it here? Yeah, okay. So if G, so our gesture, dot state equals state dot state underscore start. All right, save that. So now let's run this again. Run. I'm going to swipe across my motion sensor. Okay, there we go. And the start menu shows up. I'm going to go over to my desktop and I'm going to do a click, and we're back. So as you'll notice, start menu clicking, pretty simple because, you got big icons, but clicking on something small like this can be hard. And okay, I got it second time this time. So that is all I wanted to talk about in this video, guys. Remember to keep an eye out. I'm not sure when I'm going to do it, but I will do the speech recognition one as well. Thank you guys for watching. I know this was a really long tutorial, over 30 minutes. Remember to leave a comment on the video, like the video, and subscribe to my channel. I'd really appreciate the support, and I will see you in my next tutorial. Peace out.